Okay, it has started already. Thank you very much. In the previous class, we wrote the probability density function of a normal distribution with mean mu and variance sigma square. In this class, let me compare this probability density function with the ones we wrote for uniform and for exponential distribution, and then I'll show you what is the problem that comes up during the normal distribution. For the uniform, your f of x was 1 over b minus a, and I'm talking about the continuous uniform. For the exponential, your f of x was lambda e to the power minus lambda x. And for normal, your f of x is 1 over sigma square root of 2 pi e to the power minus 1 over 2x minus mu divided by sigma whole square. Forget about what is the domain of these variables. Now, whenever you come across a question of probability, we always prefer to convert that question into less than form, the question in terms of CDF. If it is already a question of less than, we solve it as it is. If it is a question of greater than, we use the complement rule to convert it to less than. If it is a question of in between, we also convert it to less than by using this rule. Now, when you're trying to find a less than probability for uniform distribution, obviously it is from A to a specific point X. That's the probability of less than X. This is the probability of X less than small x. And when you solve this integral, it has a closed form. It comes out that this is x minus a over b minus a, and this one is denoted by capital F of x of uniform distribution. Luckily, it has a closed form. When you do the same for exponential distribution from 0 all the way up to x lambda e to the power minus lambda x dx, this is the probability of x less than equal to small x. When you solve this integral, again, this has a closed form. This can be solved, and the solution is 1 minus e to the power minus lambda x. And this, we called it capital F of x for exponential distribution. Unfortunately, when you try to solve this integral from minus infinity to a specific value x, when you try to solve this integral, this basically is the probability of x less than equal to x. This does not have a closed form. Although it is capital F of x, but it does not have a closed form. Because it does not have a closed form, we have to integrate it numerically. Now we have the numerical solutions for this integration, but in the last class we discussed that there are infinite many possible values of mu and there are infinite many possible values of sigma. We cannot solve numerically these integrals for all possible values of mu and for all possible values of sigma. So what did we do? What we did was, in the last class we discussed, instead of solving for x directly, we convert every question into z, which is x minus its mean divided by its standard deviation. And we said that this z follows a normal distribution with 0 mean and 1 variance every time you get rid of mu and sigma. By adjusting the variable with respect to mean and standard deviation, you get rid of mean and standard deviation. And once that happens, now you can easily go to the Z table, which I'm going to show you now on your screen. Here is the Z table. Here are the solutions numerically integrated for you. This is capital F of X. Inside the table, there is capital F of X. There are less than probabilities. And at the edges of the table, and I'm going to mark the edges now, at the edges of the table, in the yellow color, these are the values of Z. Similarly, for the second positive part, at the edges, these are the values of Z, and inside the table, these are less than probabilities. All the values inside the table in the white color you see in the white background, these are all less than probabilities. These are all capital F of X. And the ones I marked with the yellow color, these are the values of Z. So if I want to interpret one of these values, for example, I choose this value. How do I interpret this value? I will say that the less than probability is 0.0073. Less than what? Less than 2.44. Look at the first decimal minus 2.4 and look at the second decimal 0.04. So you will say that the probability of Z less than minus 2.44 is 0.0073. This is what I'm going to write here. Probability of Z less than minus 2.44 is 0.0073. Let us interpret one more value from the positive side. Let's do it with this value 0.8770. You check the first decimal, it's 1.1. You check the second decimal, that's 0.06. So you will say the probability of Z less than 1.16. This is 0.8770. So all these probabilities in the table, they are less than probabilities. Now I'll take you to some of the questions directly from the normal distribution, and we will see how do we solve them. But the key is what? The key is we will convert every question of normal distribution to standard normal distribution because we have the table for the standard normal distribution, and then we will solve that question. Muhammad Faris.
Yes, doctor. Could you go up, please? To the yes. If it is Z less than or equal 1.16, will be also 0.8.
Equal or not equal does not matter.
Okay.
As X is continuous, Z is also continuous.
Okay. Thank you.
And keep in mind, this is the most commonly used distribution in statistics. After chapter 4, you have chapter 7, you have chapter 8, you have chapter 9, you have chapter 11. All four of them, they depend upon normal distribution. Let me bring a question from your book. In the meantime, if you have any questions, you can ask. This is question 4.71. From the soft copy of the book. I'm going to mark the important information with different colors. The question says the compressive strength of samples of cement can be modeled by a normal distribution. Now, whenever you will see a question from normal distribution, you will see normal distribution in the question. With a mean of 6,000 and a standard deviation of 100. Mean and standard deviation will be given. Now I'll tell you what is X. X here is the compressive strength. What is the distribution of X? X follows a normal distribution. Mean is 6,000 and standard deviation or variance is 100 square. That's the given information so far. Part A, what is the probability that the sample strength is less than 6250? Who can tell me what is required in part A? Read the question, read part A, and let me know if you can tell me what is required in part A. Muhammad Faris.
The probability x less than 6250.
Anyone else? Is this correct? Raise your hand if you want to comment. Raise your hand if you think it is correct. Raise your hand if you think it's incorrect and you want to correct it. Ahmad Raid Bazroon.
Yes, doctor.
Is this correct?
According to the question, I think yes, it is correct.
Ali Salman Yusuf. Ali, the question says, what is the probability that the sample strength is less than 6250? Is this correct, what Muhammad Faris said?
I think.
Yes, all three of you are correct. This is what is required in the question. Now, as we said that for specific values of mu and sigma, it is impossible to solve the integral for this x. So we have to convert the question to z by using this formula, by subtracting the mean and dividing by the standard deviation. So I'm going to do it now. This is going to be equal to probability of x, and I subtract mu and I divide it by sigma, less than, I'll do the same thing on the right side to balance the equation. 6250 minus mean is 6000 divided by the standard deviation is 100. Now the left side, when you subtract the mean and you divide by the standard deviation, the variable becomes z, and on the right side you will have a single value, and that single value is 2.5. Now all you need is the probability of z less than 2.50. Now the standard normal distribution table is available up to 2 decimal points for the specific values of z. It is available up to 2 decimal points. So you need less than 2.50, which is exactly 2 decimal points. So if this value comes out to be more than 2 decimals, you will round this value to 2 decimal because the z table is available up to 2 decimal. I will bring the examples where it is more than 2 decimals and I will show you how to round it. For now, we need probability of z less than 2.50. This is direct. The table is available in less than probabilities. We'll go directly to the table. And we'll go to the right side of the table, positive side of the table. And we'll check for 2.50. And the corresponding value is your answer. So I got 2.50 and I'm going to make a circle with the blue color against the value. That is your answer. It's at the bottom of the screen. Right in the left corner at the bottom of your screen, I made a rectangle against a value. This value is the probability against 2.50. Which probability? Is this equal to probability? No. Is this greater than probability? No. This is less than probability. So your answer is 0.9938. From the table, it says that the probability of z less than 2.50, that's 0.9938. So I'll go and write 0.9938, and that is my final answer. Any questions about this problem? Yes, Muhammad Faris.
Doctor, why we didn't use immediately PDF?
We don't use immediately PDF. If you want to use the PDF, you can use the PDF like this. That will be minus infinity to 6250, 1 over sigma square root of 2 pi e to the power minus 1 over 2 x minus 6,000 is the mean. 6,000 divided by 100 whole square dx. If you solve this integral, you should get 0.9938, but this integral cannot be solved analytically. This will be solved numerically. Every time you cannot solve an integral numerically.
Yes, so we always use z.
You always use the z table. If you know the numerical integration techniques, you can do that. But during the exam sitting there, it takes a lot of time, the numerical integration, you cannot do that.
Physically, huh?
So 0.9938 is the probability of x less than 6250 or z less than 2.5. They are both the same things. The same thing. I'll write that one minus infinity to 2.5, 1 over 2 pi. This is the CDF of z distribution where sigma is 1, e to the power minus 1 over 2 x z square. Z square dz. These two are same things. Both of them will give you 0.9938. Let us talk about part B. What is the probability that the sample's strength is between 5800 and 5900? So in part B, we are required to find the probability of X between 5800 and 5900. This is in between probability. So the first thing you are going to do is you are going to convert it to less than probability, and that is going to be probability of X less than 5900 minus probability of X less than 5800. Once you have broken this one into two pieces, both of them are less than, you can solve both of them separately by converting both of them to z. So you convert both of them to z. X minus mu over sigma less than 5900 minus 6000 over 100 minus the probability of x minus mu over sigma less than 5800 minus 6000 over 100. So this one comes out to be probability of z less than what is it, minus 1, minus this one comes out to be z less than minus 2, I think. Is it?
Yes.
So let me copy the table for you. And from the table, let me zoom in the negative side because we are on the negative side. We need probability of z less than minus 1 and z less than minus 2. So let us try to find the probability of z less than minus 1, which I'm going to highlight with the yellow color. This probability of z less than minus 1. I'll try to find it from the table. Who can tell me from the table? Raise your hands. Ahmad Raid.
0.1587.
0.1587. Here it is. And who can tell me the probability of z less than minus 2? Someone other than Ahmad Raid. Abdul Aziz Abdullah.
Yes, it's 0.0228.
0.0228. So we got these two from the table. Now we'll plug them in and we will get the final answer. So we have this one. I'll write it down there.
Dr. Why is Z negative?
Come again?
Why is Z negative? It's not positive?
Z can be negative. The domain of Z is from minus infinity to plus infinity.
I mean, in the calculation, it is positive.
In the calculation, X is positive.
It is 500, 5,000 and 8 minus, oh, minus 6, yes, sorry.
So probability of X between 5800 and 5900, this is equal to 0.1587 minus 0.0228, which is, you can do it on the calculator and let me know the final answer. That will be your final answer. As Muhammad Faris was pointing out something, or at least he was trying to point out something, that something was that X was positive and the corresponding value of Z was negative. When X is 5900, Z was minus 1. What does that mean? What does the negative value of Z means? Number one, the positive value of Z means that the value of X is above average. You have seen this in standardized scores. A negative value of Z means that the original value of X is below average. So both of these two values are negative. That means the original values, which were 5800 and 5900, both of them are below average. Now, what does the magnitude 1 means? Minus is okay. You interpreted minus. Minus means below average. What does 1 mean? What does minus 1 as a whole mean? Minus 1 as a whole means that it is one standard deviation below average. One standard deviation means 100 units below average. Sorry, I think I wrote it wrong. Is it? No, it's right. It's one standard deviation below average, and 5800 is 2 standard deviations below average. If it was +2, that would mean it is 2 standard deviations above average. If it is 2.5, that means it's 2.5 standard deviations above mean, and so on. Let us try to solve the third part, which is complicated. What strength is exceeded by 95% of the samples? Okay, who can tell me what is required in part C? What strength, what value of X is exceeded by 95% of the samples? Strength is X. Muhammad Faris.
We need the percentile.
Which percentile now? Yes, the first thing you need to know from the question is you need a percentile. I'll make a diagram for you to get help from.
I think
This is the
0.
distribution of X. This is the distribution of X. The middle is 6000. The lowest is minus infinity. The plus is plus infinity. And you need a value of X which is exceeded by. Above this value, there are 95% of the values. So that value is on the negative side here. Not negative side, less than 6000, I would say. So that value is here. You need this value A. This A value is exceeded by 95% of the values. Exceeded by, these are 95% of the values, and these are 5% of the values. So you need a value of X, that is A, that is exceeded by 95% of the values. Someone was raising hand. I want you to tell me now, what is this A? Which percentile is A?
.05.
0.05, or Amjad Ammar, which percentile is it? A is which percentile?
The 5th percentile.
The 5th percentile. So you need the 5th percentile. Part C says 5th percentile of X is required. My OneNote file is already lagging because the file size is getting bigger. So after this question, I will change the file. I'll create a new one and continue in that file. 5th percentile is required. Now, what is the equation of 5th percentile that you need to solve? Here is the equation. You need to solve this equation. You need to solve this equation for A, as we did for uniform distribution, as we did for exponential distribution. You solve the equation capital F of A equals 0.05, and you solve for A. But this time you don't have the analytical equation to solve. You don't have a mathematical equation on the left side. So what will you do? You will again convert to Z and take help from the Z table. How? I'm going to show you now. First, you will convert as you used to convert, you convert it to Z. So probability of X will become X minus mu divided by sigma, less than A minus mu is 6000 divided by sigma is 100. And this is equal to 0.05. Minus 6000 over 100 to balance the equation. Is that right? Or do you have reservations on what I did on screen?
This is wrong.
This is wrong. What is wrong, Amjad?
A doesn't equal 0.05.
A doesn't equal 0.05. What does that mean?
That means in the equation you put This 0.05 shouldn't be here.
It shouldn't be there.
It should be on the equal side.
I don't get it.
We remove 0.05, we put A, and then the equal, we put equal 0.05.
No, this equal is still equal. I subtracted 6,000 and I divided by 100 everywhere. Minus 6,000 everywhere. In this, look at this equation and then look at the one below it. I subtracted 6,000 from everywhere and I divided by 100 everywhere. Whatever I did, is it right or wrong? Muhammad Faris.
Doctor, I think he meant will be A minus 6,000 over 100 equal 0.05.
Okay, that's one of the opinions. He means 0.05. He means this is wrong. Why it is wrong?
Because we put A minus 6,000.
So we have to balance the equation. We are subtracting 6,000. We have to subtract 6,000 from the right side also. We are dividing by 100. We have to divide by 100 on the right side also. Why not? If you do an operation on the left side, you have to do the operation on the right side to balance the equation. What wrong did I do? Anyone? And yes, it is wrong. What you are saying is absolutely right, but I want the reason. Muhammad Ali.
The equation in the list is exponential.
The equation is inside the brackets. We are dealing inside the brackets. The equation finishes inside the bracket. The inequality is already inside the bracket. We are not talking about outside the bracket. We are talking about inside this bracket. We are talking about this equation. This is a separate equation and probability equals to 0.05. That's another equation. X less than A is one equation. And the probability of something equals to 0.05, that's another equation. So we are talking about something inside the bracket. The one inside the bracket, we are talking about that equation. So we will balance only that equation. There is an inequality less than sign for that equation. On that less than sign, we'll do the same thing on both sides of less than sign, but we will not go outside the brackets. The inequality we are dealing with, that's inside the brackets. So we'll not balance it outside the brackets. Outside the brackets is another equation. So now the equation becomes probability of Z less than A minus 6,000 over 100. This equals 0.05. You call it equation A and you stop here. Now, how do we proceed? We proceed from the table now. The equation says the probability of Z less than a specific value. The probability is 0.05. Keep in mind, this 0.05 is what? This is a probability. This is not the value of Z. The value of Z is here. A minus 6,000 over 100. Now we have to do the opposite. We have to go to the table, but now in part A and part B, we had the value of Z. We were looking for the probability. So we had the value of Z at the edge and your answer was inside the table. Now it's the opposite. You have the final answer of the probability. You need the value of Z. So you have the value inside the table, but your answer is at the edge of the table. Exactly the opposite that we did in part A and B. I'll paste the table here and let you know. The first thing we need to see is that the table is in less than form, so the equation should also be in the less than form. Is the equation in the less than form? Yes, it is Z less than something. So you can proceed here. If it was greater than, you will have to make it less than first. So because it's already less than, no problem, you can proceed. Now probability of z less than something is 0.05. So 0.05, you should find this 0.05 inside the table. That's probability. Now we'll use the inverse use. We'll make inverse use of the table. So I'm going to try and find 0.05 inside the table, and I'm going to highlight it with the green color. So let us try and find 0.05 inside the table, and I'm sure you will not be able to find 0.05. But you will find something close to 0.05. Look at the two values I have highlighted. I have highlighted 0.0505 and I have highlighted 0.0495. Both of them are equally away from 0.05. So I would say 0.05 is right in the middle of these two values. So what are the corresponding values of z? The corresponding values of z are 1.64 and 1.65. 1.64 and 1.65. So which one do you take? It depends upon you. If the value is right in the middle, you can take the middle, that is 1.645. In the middle of 1.64 and 1.65. So from the table, you can say that the probability of z less than 1, it's minus 1.645. And why did I take 645? I could have taken 1.6 minus 1.64. I could have taken minus 1.65 just to have the more accuracy, because my probability is right in the middle of 0.0505 and 0.0495. So I took the middle of 1.64 and 1.65. This is from the table, and I call it equation B. Equation B is directly coming from the table. Now you write A and B side by side. A and B side by side. I'm going to copy equation A and write it down there again. The file is seriously lagging. Okay, I have A and B. Now you equate both of them. Equate both of them. And you have an equation, and that equation is that A minus 6,000 divided by 100, that is minus 1.645. And now you can solve it for A. And A will be 6,000 minus 1.645 times 100. And you will get the final answer. And the final answer of A, that will be the 5th percentile. And it will have a unit also attached with it. And the unit will be what? The unit will be kg per centimeter square. Ali Abdul Rauf.
Yes, doctor. So if I choose 0.04 or 0.05, it won't be wrong, right?
Come again if you have, like if I was solving this question for 5th percentile, you mean if you are finding 4th percentile?
No, I mean in the Z.
Yeah, in the question, if you take minus 1.64, that will be okay. If you take minus 1.65, that will be okay.
Okay, thank you.
Yes, from the exam point of view, you can take anything between minus 1.64 and minus 1.65. Any other questions? Let me create a new page so that the things stop lagging. Let us try and solve another question from normal distribution. Okay, let's go with the same question and try to cover almost all the possible tricks that you may see. I'll not design the question, but I'll directly write the notation. Let us say for this question, there is a part D, and that part D says, find the probability that X is less than 7,000. How will you proceed? Step number 1 is same, you will convert it to Z. So let us convert to Z. X minus mu divided by sigma less than 7,000 minus 6,000 divided by 100, and you will get to the equation that Z is less than 10. Now you will not find this value 10 in the table. Let me copy the table also. So when you don't find a value in the table, what do you do? How do you proceed? You'll proceed logically, and I'll tell you how. Here is the table. If you look in the table stops at 3.09. The last available value of the table is 3.09. Nothing more than 3.09 is available in the table. I'm talking about the value of Z, not the probability. The last available value of Z is 3.09. Let me write the meaning of 3.09 for you. I have highlighted the probability 0.999 for you. This 0.999 means what? This means that the probability of Z less than 3.09 is 0.999, almost 1. So the Z distribution looks like this. There is a 0 in the middle, and there is 3.09 here, and there is minus 3.09 here. Now the Z table says that this probability, the area under the curve less than 3.09, this is already 0.999. So above 3.09, there is almost nothing. Almost 0. Almost 0. What does your question say? Now let's talk about the question. Again, I said we'll solve it logically. The question says less than 10. Now the question is about probability of Z less than 10. Where is 10? 10 is somewhere here, and you need less than. What will be the answer?
1.
1. Now I'll tell you, in every question where the value of Z is not available in the table, the answer will either be 0 or it will be 1. Now you have to look logically, is it 0 or 1? For this specific question, the answer is 1 because you're looking at the less than probability. So less than 10 is all the curve. It's 1. But if the question was probability of Z greater than 10, it would be 0. Because greater than 10, there is nothing. That is one trick you may see in the questions in exam, that the value of Z is not available in the table. What if I ask you the question that find the probability of Z between 61x between 6100 and 7000? Now one of them will belong to the table, one of them will not belong to the table. We will see how to handle it. Let me call it part E. Now let us first convert it to less than. So this will be X less than 7000 minus X less than 6100. This will correspond to Z less than 10, and this will correspond to Z less than 1, I think. So for less than 10, you have the answer, that is 1 minus. For less than 1, you'll get it from the table, and you will have this value from the table. Who can tell me what is the probability of Z less than 1? It's somewhere on the screen. Muhammad Ali.
0.8413.
0.8413. Here it is. Against 1.0. 00, I would say. That's 0.8413. 0.8413, where we are 0.8413. So you will take the difference and you'll have the answer. Another trick you may see, probability of, let us say, x less than 6105. Let us say I ask you to find this probability. When you convert it to z, you will get more than 2 decimals, I hope. X minus mu over sigma less than 6105 minus 6000 over 100. So this will correspond to z less than, who can tell me all the decimals here? At least 4 or 5 decimals. And I hope there are. Muhammad Ali, please let us know.
It's 1.05.
Is it only 2 decimals?
Yes.
Yes.
No, I'll change the question. Let's make it 6106.
1 also 2 decimals.
2 decimals.
Yes.
Let's change the question. 0.1.
3 decimals.
Now, yeah, thank you. Now tell me, what is it?
1.061.
1.061. Now, what do we do when we have 3 or more than 3 decimals in the value of z? Because the table, if you look at the table has 2 decimals. One of them is in the column and one of them is in the top row. So any question where you have more than 2 decimals, that means 3 or more than 3 decimals, you will round the value of z up to 2 decimal points. So this you will say is almost z less than 1.06, and you will proceed. You will proceed as we did. That was one more trick that you may see, and what else you can see? What is the probability that x is less than 6100 or x is less than 6200? How can you solve this question? That the strength is either less than 6100 or less than 6200. Or let me make it greater than 200. It's either less than 6100 or greater than 6200. How can you solve this? There are many ways of solving it. Muhammad Faris.
I think we use the rule of the probability.
You use the rule of probability and you call this one as event A. You call this one as event B.
Yes.
And then you use what rule?
The rule of probability A plus probability of B minus probability of A and B.
You mean this?
Yes.
Yes. Now who can tell me? Okay, first part we already solved it. This is z less than 1. And this is, we have the answer. Who can tell me how do we solve the second part? Greater than 6200. Can this be solved? Yes, Muhammad.
No, we need to convert it less than.
This will be 1 minus probability of z less than 2.
Yes.
And what about the third part?
I don't know.
Who can tell me what will be the third part? Muhammad Ali.
It equals 0.
0. Yusuf Zaid.
Also 0.
Also 0. Someone else. Amjad Ammar.
0.
0. It is 0. Because there cannot be a value of x that is less than 6100 and at the same time more than 6200. So there will be a big 0 here. So you will solve all these equations to get the final answer. What if I tell you more tricks? What if I tell you G and then H? What if I ask you to find probability of X more than, let us say 6200, given that X is already more than 6100? I tell you that X is more than 6100. What is the probability that it is more than 6200 also? How will you proceed? Muhammad Faris.
We use the rule.
Can we write it probability of X more than 100 by using the memoryless property?
I don't understand your question.
The memoryless property of that we studied
No,
last
Yes, we don't use
last
it.
class.
No, we
More
can.
than 6100, more than 6200, just take the difference and write it
No,
directly.
we cannot.
Can we do that?
No, we cannot. This is only for exponential distribution.
That is only for exponential distribution. So we have to solve it by definition. And the
Yes.
definition says that you have to solve it like this. X more than 6200 intersection X more than 6100 over X more than 6100. Now, who can tell me what is the numerator? The intersection, the common area between more than 6100 and more than 6200. Abdul Aziz Abdullah. Abdul Aziz Abdullah, we cannot hear you.
Yes, it is x greater than 6200.
It's X greater than 6200. Who agrees with it? Ali.
Yes.
Is it right or wrong?
I think it's right. I agree with him.
Abdurrahman bin Al-Ghazwani.
Yes, doctor.
We're talking about the numerator. Is it right or wrong?
It is right.
It is right. Ahmad Ismail Maki. Mansoor Naji.
Yes,
Is the numerator right or wrong?
I believe it's right.
It's right. Yes, it is right. The common area between 6100 and 6200, I'll show you how it goes. There is minus infinity. There is plus infinity here. There is 6100 here. There is 6200 here. Event A says more than 6200. That is this one. Event B says more than 6100. That is this one. And you can see that the common area between two of them is yellow one. Ahmad Ismail.
Yes, it's right, I think.
It is right, yes.
Thank you.
So both of them are greater than probabilities. So you will take the complement of both of them and you will solve them by definition. The point here is that we cannot use memoryless property for any distribution other than exponential. We have to solve it by definition. Now we had a question that what percent of the samples are exceeded by, what was the question? Part C. What strength is exceeded by 95% of the samples? You said this is 5th percentile. What if I slightly change the question and I write the question, what strength, I'm sorry for this, what strength exceeds 95% of the samples? What is this question about? Amjad Ammar.
The 95th percentile.
Muhammad Faris.
Yes, the 95th percentile. Because
Any
we don't have
comments?
pi.
Anyone else? It's just the difference of exceeds and exceeded by. Ali Al Hassan.
Yes, 95.
It's just the difference of exceeds or exceeded by, but yes, all of you are right. This is now directly 95 percentile. Now you're looking for a value below which there are 95%. This value exceeds 95% of the samples. Above it, there is only 5%. So this is directly 95th percentile. I'll write it here. This is P95, but this one is P05. So you can expect the question to play around with words, and this is the most common word that you will see being played around in the exam: exceeds or exceeded by. So make sure you practice enough to know what are the meanings of exceeds and exceeded by. Okay, let us stop here in this class, and in the next class we will cover some more topics related to the normal distribution. There are some other distributions linked with the normal distribution. We will try to cover those topics, and maybe tomorrow we finish this chapter, and the day after tomorrow we start with chapter 7. And chapter 7, consider it as a section of chapter 4. It's not a full length chapter. It's just a small section. So it's just an extension of normal distribution. We will talk about that one. So if you have any question from today's class, in today's class, we entirely talked about the normal distribution. If you have any question, you can raise your hands and you can ask the questions. And if you don't have a question, you are free to leave the session now. Ahmad Ismail.
Doctor,